In this equation, we're gonna encounter the complex power. The complex power is the power that has the real power and the reactive power. So the complex power will be in the form of this one, and it can be calculated from the VRMS multiplied by the conjugate of the IRMS, which will be in the polar form with this notation. The apparent power is the magnitude of the complex power. You can see that it is this term here, or you can use the Pythagoras theorem to calculate the apparent power. The real power come from the C is equal to R plus Jx. This is the power from the real part from this, and this is the power from the imaginary part. And this is the power factor, which is the cosine of the theta of V minus theta of I. Let's get started with the A sub-problem. I've listed all of that we've known from the given information. I want to first find the theta V minus theta I here by using the trigonometry function, the PF. So the arc cos of this is equal to this one. So it's equal to, which is this one. Then we want to know the theta I, which is, we know that the VRMS phasor is equal to 0 degree, right? So we solve here, we get that the theta I will be the minus of this value. Now, from what we have known right now, we know that if we use this equation, we can get the S value. The S is the apparent power. We know P, we know the power factor. P is equal to S cos theta V minus theta I. Know that S, so we get S apparent power is equal to this VA. Then we know that this is equal to this one with the degree of power factor. Which is equal to this one. Now we know the complex power of the L. Now we want to know the IL here. So we can calculate the IL from the IRMS from this formula. As IRMS here. Let's go to this one. The IRMS will be equal to this value. Ampere. Don't forget that is the magnitude here. From the property, we know that the IRMS is equal to the IL divided by the square root of 2. So IL will be root 2 of the IRMS, and we know that the IRMS is equal to the magnitude here and the degree of theta I that we have calculated previously here, which is this one. So now we've got this value. Ampere, right? Now we have to find the CL here, which we can calculate it from the two formula here. We've got P is equal to the IRMS square, or the magnitude here, multiplied by R, which is this one. IRMS magnitude so calculate it for the calculator. We'll be throwing in this value, and then for the imaginary part, we're gonna use the Q is equal to this value, and then we know that the Q we've got from here. So Q is equal to X and Q X. So X will be equal to this one. So we've got the CL is equal to this plus this. From the previous question, we have calculated the C of the load here. So now we want to know what is inside the load. So we've got this form of the impedance of the load. So we've known that it has a real part, which is the resistor, and the imaginary part, which we kind of don't know what it is, but we can know exactly what it is by the sign of the impedance. If it's a positive, it would be an inductor, and if it's negative, it would be a capacitor. So we can redraw it this one with a inductor here. And we know more that the CL is equal to J omega L. This is equal to this, which I have to tell you more that in this system we have the frequency equal to 50 Hertz, which means that we will have an omega equal to 100 pi radian per second. And we want to know the L, so we leave it here, and after some calculation we will have the L is equal to 3.7 Henry. In the last question, we want to indicate the value of the Vs and its power factor. And in this circuit, it is obviously that it is connected in series and it is related to the voltage. So the formula that is popular in series circuit is the voltage divider. So the V is equal to plus this over by the summation of the two impedance multiplied by Vs, but we have to convert this to be back to normal value by multiply it with the root 2. So this would be this value volt, and don't forget to add the phasor here too, which I forgot in the first place. So it's Vs by this term here. So I'm gonna calculate this term first. And this will be divided by this term, which the result you will find it by the calculator to be this value. Volt. And we want to also calculate the power factor of it, which can be calculated by the cosine of theta v minus theta I. And we know that it is a series circuit. The I will be the same as we calculated for the previous question, and the theta I is this value. Go to cosines of plus and the theta v is here. So after the calculation, we got the power factor to be this value. And that's all for this question.